Welcome back to All This Math. And also, if you're not already following the Instagram page at All This Math, you can see that right here, written sideways though, at All This Math. Go ahead and follow the Instagram page as well. The reason being is because that's where you can submit requests through the DM. You can submit requests of math problems that you would like to see on this YouTube channel. All right. Also, there's going to be content on, or there already is content, and there will be even more content on the Instagram channel as well, or the Instagram page as well. All right. Now, let's get into today's lesson. Today's lesson is about dividing fractions. All right. So we see this example behind me. It says 3/4 divided by negative 2/3. So what we're doing is we're dividing a positive fraction by a negative fraction. We're dividing a positive fraction by a negative fraction. All right. Now, one of the things you want to think about is the fact that this negative, the fact that this is negative doesn't really matter until you are finished with the problem in terms of the work and how you work it out. This negative don't really make a difference until you get to the last step. You gotta have memorized the rules for multiplying and dividing numbers in general. When you divide a positive by a negative, your answer or your quotient, 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 your quotient is always gonna be negative. So write that down and memorize that. Whenever you divide a positive anything, it could be a fraction, a decimal, a whole number, whatever. Whenever you divide a positive number by a negative number, your quotient or your answer is always gonna be a negative. All right, so commit that to memory. But for real, that don't even come into play until your last step. You don't even gotta worry about that, right? As you're going through the steps and everything, going through the motions of actually doing the problem. Now, before we get into the actual procedure of how to do this, I want to make sure conceptually we have somewhat of an understanding of what's really taking place here. So again, let's imagine this is not even negative. Let's imagine it's positive. So we're saying 3/4 divided by 2/3 if we imagine that they're both positives, right? So what we're trying to say is, or what this problem is trying to say is, how many of this thing can fit into this thing? That's all that's happening whenever we do division. Whether you're doing division with two whole numbers, whether you're doing division with two fractions, whether you're doing division with two decimals, whether you're doing division with a whole number and a decimal, all we saying is how many of the second thing can fit into the first thing. So in this case, how many groups of 2/3, how many 2/3 pieces of something can fit into 3/4 a piece of something, right? Because here we got two different fractions, right? So I know that 2/3 is less than 3/4 because the way I think about it is I do conversions to decimals, and I know that 2/3 is like 67 cents, right? 67 cents out of $1. I know that 3/4 is like 3/4, and we know a quarter is 25 cents. So 3/4 is 75 cents. So I know that 67 cents is less than 75 cents. So if I'm thinking how many 67 cents, how many groups of 67 cents can fit into 75 cents, I know that since 67 cents is less than 75 cents, I know the whole 67 cents can fit into 75 cents and some more, and a piece of another group of 67 cents. So since I know that going in, I already got an idea what my answer is going to look like. You know what I'm saying? So the most common way though to actually do the problem and do the work is we use this method that people call keep, change, flip. Keep, change, flip. KCF. Not to be confused with KFC, right? Keep, change, flip. KCF. Let me write that down for you, because that's something you should memorize. KCF. Keep, change, flip. Now you might, if you never heard this before, you might be wondering like, well, what you mean keep, change, flip? What am I keeping? All right, I'm gonna tell you. So basically, this outlines, keep, change, flip outlines what you actually do to this problem. So what we're going to do is we're going to keep the first fraction. We keep the first fraction. The first fraction is 3/4. So we keep that. We don't change that, right? So basically what I do is I rewrite it. 3/4. I keep that. Then we change, the C stands for change. We change the division sign. The division sign, what does it change into? Do it change it to a plus sign? Do it change it to a minus sign? Do it change it to a square root sign? No. It changed into a multiplication sign. All right? It changed into a multiplication sign. Now we can use the dot for multiplication, or you can use the X for multiplication. Some people use the asterisk for multiplication, but I'm gonna use the dot for now, right? So we keep the first fraction, we change the division sign, and then we flip the second fraction. Now remember, you always flip the second fraction. You never flip the first fraction. That's a common error. Don't flip the first fraction. A lot of people remember the flip part, but they don't remember the order sometimes. They make the mistake and flip the first fraction. You always flip the second fraction. That's why it goes in order. Keep, change, flip. From left to right. Keep, change, flip. It goes in order. You know what I mean? So we're going to flip that. Now, mathematically, we would call that taking the reciprocal of this fraction. A reciprocal of a fraction is the fraction that can be multiplied by the first fraction, which will give you a product of 1 or to make it whole, right? So when you hear things about like reciprocity, like two people coming together and they have reciprocity, they become a better unit and a strong unit of 1, right? So here we flip, meaning, think about bunk beds, right? If you and your sibling share bunk beds and then one day y'all decide, all right, well, we're going to switch bunks. You know, if you stay on the top bunk and then you say, you know, to your sister or your brother, like, yo, listen, I want to come down to the bottom bunk. You come up to the top bunk. I want to switch up. You know, I want to see what it's like sleeping, you know, in the other bed or whatever, right? That's the same concept that's going on here, because this 3 is going to become the numerator and this 2 is going to become the denominator. Now, but it's still going to be negative though. That's not going to change. So this is going to become times 3 halves. All right. So now we got 3/4 times negative. Let me put the parentheses right there because that negative sign might get confusing. 3/4 times negative 3 halves. All right. Now that's our new problem. So it becomes a multiplication problem. Now there is a way that we could divide horizontally, but in this particular problem, if we did divide horizontally, it would just make the problem more complicated anyway. All right. There are also problems where you can divide horizontally. A lot of teachers don't talk about this, but there are some division problems with fractions where you can just divide horizontally and you'll get to the answer, right? And that works, but we could also, actually, you could do that like I said, you could do that in this particular problem, but it creates more problems because you're going to end up with what we call a complex fraction. All right, you're going to end up with what we call a complex fraction. So let's just go ahead and multiply. Now, for the next step, I'm gonna go vertically, so I don't have to move all the way over here, you know, but I'm gonna go vertically so you can see my work. So now I'm going 3/4 times negative 3 halves. So I'm multiplying numerator times numerator, top number times top number. 3 times 3 is gonna be 9, right? And then denominator times denominator, 4 times 2 is gonna be 8. Now, don't forget, this was a positive times a negative. Positive times a negative, in that situation, the quotient is always going to be negative. So I put my negative sign right here. And how do I know that I'm done? I know that I'm done because I can't reduce this. I can't reduce negative 9 over 8. How do I know I can't reduce it? I can't reduce it because the greatest common factor between these two numbers is 1. And whenever your greatest common factor between the two numbers in a fraction, numerator and denominator in a fraction, is 1, you can't reduce it. There's nothing else you could do. That's how you know you finished. All right. If that wasn't the case, if they had a different greatest common factor besides 1, then I would go ahead and reduce the fraction, and I would get a fraction with different numbers in it. But for now, we have negative 9/8. So this kind of like coincides with what I thought from the beginning. How many 2/3 can fit into 3/4? How many of these can fit into these? A whole 2/3 and then some. Now, I'm gonna show you why that looks like that, because this actually, I can convert this. I'm not reducing it, but I can convert it to a mixed number. 8 goes into 9 one time. That's my 1. With 1 left over, 9 minus 8 is 1. So that's my numerator. And I keep the denominator of 8. This is just straight conversion from improper fraction to a mixed number. What's an improper fraction? A fraction that has a numerator that's bigger than the denominator. What's an improper fraction? A fraction that has a numerator that's bigger than the denominator. So this is really negative 1 and 1/8. So that kind of goes back to what I was saying in the first place. Like, how many 2/3 can fit into 3/4? A whole 2/3 can fit into 3/4 because a whole 67 cent can fit into 75 cent, right? But what about that extra 8 cent? That extra 8 cent is right here in this 1/8, right there. That's that eighth right there. That's that extra 8 cent. 8 cent that fits too, right? So you got the whole 67 cent. That's the 1, right? That's this right here. Then the difference between the 75 cent and the 67 cent is going to be this 1/8 right here. So that tells you how much or how many of these can fit into 3/4. A whole one of them plus a fraction of one of them. A whole one of them plus a fraction of one. I know you might be looking at that like, hey, that's crazy. Like, how can you have a fraction of a fraction? You can. You can have a fraction of a fraction. Then you can have a fraction of a fraction of a fraction. You can have a fraction of a fraction. You know, you get my drift. It goes on and on and on. All right. So basically, this is how you divide fractions. And I also just want you to think about, because a lot of times, like when I was younger and I was in school learning this, I never learned the concept of what really dividing means. I was good with keep, change, flip all day. That's just an algorithm. That's a straight algorithm. I memorized that. I could do the problems, but I never understood like what division really meant with fractions. The fact that it meant that, you know, we're trying to find out how many of these can fit into this right here, right? And the same concept applies with whole numbers or integers, you know? So, all right. So again, like I said, make sure you follow the Instagram page because we have content on the Instagram page. Also, that's a way you can send through DM. You can send requests for problems to the Instagram page, and then I'll find out about that, and it will hopefully, you know, it will end up, your request will end up as a video on the YouTube channel, right? On here, which I hope you also subscribe to. Make sure you subscribe to the YouTube channel and make sure you tell some other people about it, because this is a place where you can come to learn math, right? You can get reinforcement. You can come here. You can, if you don't understand something in class that your teacher went over, come here. I got you. I'm gonna hook you up. All right, just come through. All right. Until next time, go get some practice.